Hello, and welcome to another episode of thenet.lol. Today I am joined by two of our co-hosts, Dave Tucker and Brent Salisbury. Tom Nadeau couldn't be with us today. And we're very excited to have on as a guest today, Nancy Winget. Nancy does a lot of work in the IETF, and I know she does a lot of things with security and encryption, so it's going to be an exciting show. So Nancy, welcome to the net.lol, and could you tell us a little bit about yourself?
Sure. So first, thank you for having me here. I look forward to an engaging dialogue. I'll put it that way. So I actually started in the network security side back in the early 2000s when there was a thing called IEEE 802.11 and the whole notion of wireless security came to light. And I actually started in a small startup called Atheros, where we were trying to vet out .11. And even a week before I started, there was the whole panacea of how do we secure 802.11 because of the whole web panacea. So, you know, my whole journey since then has been very much about the network security. And of late, I've been looking more at the trends to increase security, but also paying better attention to the privacy. And that gets into some of the tension with the protocols, if you will, right? And the evolution of them as they're gaining popularity in how much gets the encryption. And encryption here goes towards addressing both the confidentiality as well as the authenticity, right?
Yeah, definitely. And I think especially, given the world we find ourselves in today, these are all very interesting questions for a variety of reasons. But
Absolutely.
Definitely for sure. I mean, you're seeing it now, right? I mean, everyone's talking about end-to-end encryption, for example, as what that is, and
Right.
There's various government agencies that have opinions on that sort of thing as well. But if you could, so you mentioned protocols in that as well. So is a lot of the work you do involved in the IETF, and how does the IETF involved in some of this?
That's an interesting question. So when I started in the network security, it really started, my security career started with the IEEE camp, 802.11, and then 802.1x. But then to secure these protocols, we needed authentication mechanisms, which then got me into the IETF, right? So now as you look at the future trends of everything getting into distributed computing with cloud and all of that, the way I look at it is the trends have been moving up the OSI stack, if you will. And so more and more, I do find myself deeply entrenched in the IETF, not so much in the IEEE anymore. It's going up to the TCP layer and above, right?
Yeah,
so, admittedly,
it's like security's followed the rest. Yeah.
Exactly. So it started with, now that we feel that the link layer is on the right path, how do we get to the stronger authentication? And now as we get into the cloud compute, and really the pervasiveness of the use of TLS, if you will, right, is where I've gotten far more involved in the IETF. Interestingly enough, I'm not as active in the TLS working group as I am with all of the other things that are needed to bolster, if you will, right, the privacy and security considerations around the data communications security.
Yeah, that's very interesting, and I apologize. I was saying before that the security is following everything else, right? Whereas, we used to all talk about layer two and broadcast domains, and now no one wants to talk about layer two.
Right.
It's all layer three and higher. Security is following kind of that stack, I think, if you would as well.
Right.
So,
Right. And
sorry, go ahead, Nancy.
I was just going to say, yeah, I was just going to say it's interesting that you say security follows it, because one of the things in the security community, it's we very much want to be in the start of the conversation, right? Security has to be in that forefront. And in the last few years, not just because of, well, not just because of regulation, but because of the pervasive use of the internet, right? Where when we started with the whole use of network, I'll say, it really was the enterprises and the commercial space using it. But if you look at today, who doesn't use the internet, right? And so that got us into the notion of the privacy issues that come to light. And so now there's that discussion of security and privacy, right? Which is why we're now seeing that increased use of these secure protocols.
So, and it's interesting you say that kind of the security side of it as tailing the network. I almost think like the mechanisms for us encrypting the network itself kind of went in that same kind of progression, right? So we start out with IPsec, and we're going to say, the underlying network is what's encrypted and secured, and there's no guarantee for the application on top of it, but we can at least tell you that the underlying network is secured. And then we, things like PCI
Right.
DSS, I think probably drove that.
Yes, to a great extent. It got to the notion of, can we rely, and so again, it gets back to the use of the network that then led to what we know today as the internet, right? So initially you could rely on the physical security, if you will, right? It's like, well, nobody can infiltrate because our computers are locked in, some closet in the building, to now you have, and I think it started with just having mail connections, if you will, right? And so now you get into the need of, well, even within the same enterprise domain, if you will, right? You now have the notion of how do you affect, right, protections. I'm not sure that we even used the word security back then. It's like, how do you guard the fact that you now have two buildings that are not, two computers that are not in proximity communicating with each other. And now if you just roll up to now with the internet, it's and the wireless medium, it's anybody anywhere, especially with the wireless medium, you could eavesdrop, right? So the whole notion of the physical security goes away, and that's where it gets to the question of how much do you secure when you look at the network OSI stack, right? And of course, most of us, if not all of us in the security, network security, will say all levels of the OSI stack should really be secured. But then when we talk about security, it gets to the notion of how do you provide the solution that affords that level of security? And that's yet another long topic, right? But this is where I think earlier on, the whole task of how do you provide the security? It's not just about so you mentioned IPsec. So IPsec talks about the protection of the communication. Well, in order to do that, you need to do some level of key management. Well, how do you make sure that the owners, that it's the right parties that have the keys? So that then gets you into the authentication, right? But then with the authentication, it's like, well, how do you ensure that that person is not only that person, but is actually authorized to communicate with you securely, which gets you to the authorization. And that's where you've seen the growth of, it's not just IPsec, but you need IKE. And today, right, I actually prefer to use the TLS stack for doing the communications, just because it gives you a whole state machine that affords the key management with the ability to do the authentication that then leads you to that communication protection, right?
And it's interesting that you bring up TLS as well. And actually, this from the discussion, from what you were just saying, it's when you start to think about where we are today, I feel that a lot of the security has even evolved into the app. And I think that has to do with a lot of different things. I mean, not the least of which is these kind of, large internet hyperscalers, such as Facebook and Google and some of these, and Apple, right, that want that end-to-end encryption from not just the device, into the app, all the way through. So there's that. But I think it's interesting. And can you tell our listeners a little bit about TLS 1.3 and maybe even touch on ESNI a bit and why they should care about these new protocols coming out?
Sure, absolutely. So TLS, as you will, if you look at the history of TLS, and again, it was the beginnings of the internet, where we had, I'm not even sure we called it HTTP, when we had web applications, right? And so I think it was Netscape who found it the way of, now you can launch, a web, here's an application. I'm not even sure that browsers were still called browsers back then even, but there was the need to get up to that application layer, if you will, that leads to the explosion today of most of the applications being accessible through the web, right? But when you look at the history, there was already the recognition that there needed to be protections. And that's where SSL was created with the increased adoption of the web, right? There was a need to formalize it and have it turn into a more standard form, if you will. And so I won't get into the politics. SSL then became TLS in the IETF, and thus TLS 1.0 was launched. And so again, through that arms race, if you will, between the industry growing with the disruption and the adoption of what we know as the internet today, with the hackers to the threat activists, right? More and more vulnerabilities, not just in the implementation, but I'll say in security gaps in the protocols themselves, is where we got from TLS 1.0 to 1.1 and 1.2. When you look at the history behind the TLS, there's been a growing adoption, and that's how I got into the TLS world, not so much from the SSL or the web side, but from the notion of here's a protocol that is well understood. It provides all of the properties that we need. We can actually optimize it as well. And so let's just use that as the ability to secure other layers on the OSI stack. Okay, and so that's where I got introduced to TLS in the notion of let's use TLS to establish secure tunnels, even at the link layer, right? And so that's where I introduced the use of EAP TLS, but then needing again to come up to a more rounded solution, which then got us to EAP FAST, which uses TLS as the underlying tunnel creation, right? And so now where we're getting into the inflection of the notion of we have to provide security as well as privacy. What's happened in the evolution of the TLS leading up to 1.2, what's happened is when you look at TLS 1.2, there's a whole bag of tricks, right? So you can use, all kinds of different types of certificates. There is a whole long range list of cipher suites that you can also leverage. But at the end of the day, it was the notion of how do we simplify the use of the protocol? That's number one. Number two, how do we enforce the best security practices in establishing that secure communications? And how do we optimize the performance, right? And so you could now think of, TLS 1.2 in its initial creation as being very chatty, because to actually secure that tunnel, you did the initial one, you require 5 messages, right? And so I'm one of the culprits that introduced things like TLS ticket and, bolstering its security by doing the crypto binds and all of these things. And so we tacked on a lot of extensions to bolster that security. TLS 1.3 cleans all of that, as well as improving on that initial session establishment from going from 5 messages to 3, right? It also helps with the notion of ensuring the best security practices, if you will, by in those 3 messages. Effectively, to me, it's decoupling the key management from the authentication establishment, if you will. Whereas before we could use things like RSA static keys, which is really not a good practice, but it's still in use because it does help with some of the monitoring that's needed in some of the use cases. But in TLS 1.3, what we now do is we first ensure that the 2 peers, nobody in the middle can interject, that it really is the 2 peers that are establishing that secure tunnel, right? And then in the cipher negotiation, we've gone from that whole laundry list of, the AEAD, the associated encryption algorithms, right? Authenticated encryption algorithms to down to just a handful to really serve most of the use cases that we need to today. And so the predominant one that's in use is still an AES-based, but if you really want to be performant, then there's the new Cha-Cha cipher suite. So that's kind of a very high-level notion of how we got into TLS 1.3. We also try to address the, how we can deal with the ossification and how do we deal with the back legacy negotiation, if you will. But I'm not gonna cover that as much as I will, because you mentioned the whole ESNI notion, which gets us into the discussion of privacy, right? So
right.
another goal that TLS 1.3 strives for is improving that privacy. So I already mentioned, right, and that decoupling to establish that secure tunnel and ensure that it's really the 2 peers. We use that ephemeral Diffie-Hellman, if you will, to ensure that it really is the 2 peers. But now if you look at the TLS protocol, we have other extensions, right, that gives network operators, if you will, hints about where that client may be trying to communicate with, right? And that goes through to the ESNI extension. And so the ESNI, I say, gives you a hint because it gives you the main domain it's going to, but it may not give you the true application that is being used, but it at least gives you a hint, right? I know that it's going to Google, I know that it's going to Facebook, but it may not give you that it's using, a YouTube versus Gmail, just as a course level example. And so to some use cases, that is construed as leaking some private information, right? And so in TLS 1.3, what they've defined is a way to protect that SNI so that it is encrypted. And so to me, it's basically responsibility one level up. And so now we can talk about, how DNS resolvers come in, which we may not have time to get into that discussion, but there are ways now in which you can protect the SNI. And so that guidance and how to get that interoperability has been standardized. I don't know that we can call it a standard because it falls out of the scope, because now you need to talk about the provisioning, right? There needs to be some other entity that actually encrypts that SNI. So what's interesting is in the formulation of coming to how do we protect the SNI, there was the observation of, well, gee, there's other extensions that could be construed as leaking some level of privacy, right? So like the ALPN, for example, right, to choose one, and as well as some other extensions. So there is another document and work underway in the TLS 1.3 that is actually looking at encrypting as much of the client hello as possible. So you will see activities that talk about encrypting the whole, client hello message, when in fact you still need enough of the header as well as the cipher suite, right? But so there are some efforts underway to show how that can be done. But as you can see now, there may be other challenges that come into play, right? That I have no doubt that they will make progress, and it will serve some use cases to address that as well.
Yeah, and one thing that stands out to me is, and this is a challenge, is, it feels like there's that it's difficult at the protocol level to distinguish between whose privacy we're trying to protect, because are we trying to protect the user or the application, right? And I feel like they could be two different things. And as an example, let's say that with TLS 1.3 and ESNI, I buy something off of Amazon, right? And that thing I buy off of Amazon, some Internet of Things device in my house, and I put it in my house. And if it's using TLS 1.3 and ESNI, I have no visibility into where it's going or what it's doing. I mean, as soon as I put it on the network, it's opaque to me. And as we saw with like Google's Nest products, these things may actually ignore the DNS servers that you return in like a DHCP query, for example. They may hard code themselves to specific DNS servers, so you lose that visibility too. So and then they're using DO or DOT to there, right? So it as a user, and maybe this is what our listeners are confused about too. Like it seems like there's competing privacy demands here. There's the application, and then there's me, the user, and I feel like they're in conflict at times.
Right. Well, so let me answer you. Let me try to address that by giving you another question. Right. When you say me, right, there's actually different audiences that we're speaking to. I believe, and use cases, right? And so there's the human, the end user, right? And the end user plays a role, right, as well as the applications. But now there's the device, right? And so the device, and usually in the device, I refer to it as the OS or the platform vendor, right? Also tries to provide some level of protection afforded by the device. But now when you look at the internet, there's also, especially when we talk about the web-based applications, there's the browser. And the browser is trying to come in and provide that level of protection as well as the application. Let me add one other entity in there, and that is the enterprise, right? And I say enterprise because I don't know of another better word to use, right? But if we are employed by somebody, we're using devices, right, to carry out our work on behalf of that enterprise. And so they also need to provide some level of protection to not just the user, but to their own corporation as well, right? So the question I have for you is, when you say I, right, which I are you referring to? Because there's the ecosystem now, and now with the SolarWinds attack, right, we now get into the whole supply chain question as well.
It's a very complicated topic, and I agree. And I think you did a good job of.
Yeah.
I mean, there's so many layers, and that's right. I mean, when I say I, it's you could be any of those layers, and it's I mean, it's a challenging problem to solve. And we didn't even, and then we could also get into identity, I think, which adds another layer to it as well. Like, what does the identity mean, in different terms? I mean, it means different things to different layers of the stack and different protocols and things as well. So, yeah.
Right. So I do think we are in that challenging phase right now, right? And that's why I ask you, right, what do you mean by I? Because as we're evolving the communications, right, meaning the protocols and the interfaces, we do have to outline the use cases and be very careful, especially in the in the security space. And I like the way you framed the privacy question, right? Who are we trying to protect when it comes to privacy? Because it does get to leaking. Yes, we absolutely have the regulations of PII, right? The personal information of users, but then there's also the information about the enterprises. And it's interesting because what may be private to one company, another company could care less, right? It's like, fine, they could have that information. But when it comes to designing these protocols and interfaces, it does get back to, which ones do we want to pay attention to and which ones do we just forego, right? And so that is an interesting challenge that we're faced with today, even with TLS 1.3, right? Because we have been living with, the high level of adoption that started with 1.1 and now with 1.2. When you look at the adoption rate of TLS 1.2, it's massive, okay? And it's massive not just at the application layer, but I mentioned, I got into it because it was a perfectly good, usable, from a performance, security properties, and we could even argue the privacy properties for the link layer, right? Whether we're talking the Ethernet or the wireless stack. With TLS 1.3, we still have that tension of, and I'll say, security and some of the privacy preserving goals that we have, right? Because when we get into the, I'll say the healthcare and the financial industries, there are circumstances in which they will, and I'll come back to, the SolarWinds example, which is the supply chain, right? At some point, depending on that chain, right, we we need to have enough of the auditability perspective, and I'll put aside because there's the forensic aspect as well as the dynamic monitoring and visibility that's needed. And that's the tension that we're living in today as we're moving forward to, we need to update, which is why DOE came about, right? I think DOE came about because we really needed to come up with a better way of providing the ability to provide some level of confidentiality, right? And so while there are quite a few DNS resolvers that have authenticity behind the DNS, right? So whether it's DNSSEC or proprietary, an umbrella uses DNS script as an example. Confidentiality was missing, which is why DOH came about. And so now we get into that tension of we're beginning, so when I say we, those that are providing that level of monitoring or visibility, right? And the visibility now can come into not just the monitoring, but even in providing better performance, right? Or even just providing you visibility into your current security posture, right? Whether it's for compliance or for the threats, right? That gets to be more and more challenging into how we create solutions that balance, right, the need for the privacy, as well as the need to provide the protections. Right. And I might even argue that even in the privacy side, you still need some level of visibility to know that yes, you really are complying with the privacy guidelines. Right.
It's a tricky balance, isn't it? I was going to
It
say,
is
I remember, as a network operator, one of the first things that we had to do was install a load of middle boxes that intercepted all of the TLS. Because we wanted to know what was going on, right? I've got to scan all of that stuff. I've got to make sure that it's fine. I think that obviously it sells boxes and that's great, but I think we're getting to a point now where we ought to be looking at the network and saying, you know what, privacy by default is totally fine because we control the edge devices. We control the devices either end of this link, and we can probably protect them at the edge as opposed to having to try and do it from a network-centric approach. It's not always a network problem, I think.
Another thing, Nancy, I think it's impressive that you actually versioned to 1.3 and actually took stuff out. That's so rare. Normally it's let's add a bunch of garbage and every vendor wants to stick their extensions in. So
right.
Congratulations. I mean, the simplification, I mean, most people listening to this, unless they are, probably security professionals for a long time, are going to have to be Googling a lot of acronyms, right? So that
right.
idea that,
yeah.
Like you guys are actually keeping in mind simplifying this out for the user side, I think is impressive. So a question, one thing I've never, whether it's HIPAA, you mentioned healthcare, whether it's PCI, which is, for those out there don't know, so it's the credit card regulatory piece. I never saw, those are so nascent because the technology moves so fast, the exploits move so fast. I never really understood. I mean, I always an audit always kind of felt silly, right? Because it's some check boxes that made sense probably 18 months ago, which is probably not operative anymore. So it really is, I mean, it's roulette. If you don't invest into doing your own due diligence outside of just checking boxes, you're going to make a headline someday if you're big enough.
Absolutely. I mean, I look at the regulations as a way to force you into the conversation, right? But you're absolutely right. I mean, at the end of the day, right, no matter how many regulations and how many certifications there are still going to be, I was going to use the word conflict, but it's the notion of how do you keep pace with the technology and how do you keep pace with the hackers, right, and the threat actors when, as you say, the regulations are there, and again, to reiterate, it's really there to help you set that stake in the ground to do the right thing. I'll give the PCI this credit into which they foresaw, right, that they needed to do something to try and keep a pace, right? And so when you look at their document, they do have comments to the, you need to keep that monitoring. And so you can say that there are places in which if you took a black and white interpretation, you could say, oh my gosh, these are conflicting, right? But when you look at it from the intent, right, it's by and large, they're trying to ensure that you are using the best practices. But where I'm saying you could see some of the conflicts, and this gets to my comment of the mass adoption and acceptance of TLS being a good way to secure the network communications, is when you look at the PCI document, they do say, right, on the one I noted, right, you must monitor. But on the other one, where they talk about securing the communications, right, they absolutely say you should be using the latest version of TLS, right? And so now people who are trying to deploy their solutions, they're going, okay, so I need to start looking at the roadmap for how do I set the stage for TLS 1.3? Oh, but wait a minute, my middle boxes won't work, right? How do I now start evolving my solution so that I can stay abreast of, what the PCI regulations want me to do with what's happening with industry and the standards, right?
Yeah, and it almost feels like checkboxes to open up the purses for OPSEC too. Like, well, it's got to be PCI,
Yes.
so we need another $3 million for this project, which is, I'm not saying it's necessarily a bad thing.
New firewalls, yay.
Yeah. Right. But I mean, it is interesting because as I continue to improve on the security solutions and now trying to be respectful of privacy, there is that level of complexity of having to, you're always going to have some level of configuration. Kyle, you mentioned identity, right? It's like, how do we store that? And so it'll be interesting to see that evolution because now that we're in the pandemic, we've got pre-K, little children using the laptops. It's like, how are you going to expect them to remember a password? So it'll be interesting to see the evolution of how the authentication solutions come to play. And so this goes to my security link, if you will, right? You need the authentication so you can establish the authorization to give you the keys to the vault, if you will, the vault being, right, the secure communications and access to the data resources.
So I can tell you for sure.
Have.
I was going to say, I can tell you for sure, having a kindergartner, I can tell you for sure how authentication and identity works on his iPad. There is none. You open it up and you're into the apps. And I think the school district's done that on purpose. But
it's us, right, Kyle? We are the authenticators. We have to sit there and manually verify everything before they're allowed to use anything. It's terrifying.
Right. But see, there you go. Now, whose privacy are you trying to protect, right? And so it is, I mean, we're still in that evolving cycle, right? Yeah.
So as we're talking about SSL and TLS, obviously one of the things it's being involved in the open source community that comes up very often is OpenSSL and all of the vulnerabilities that have come from OpenSSL. I guess one of the interesting movements in the last few years has been the formally verified cryptography libraries that have started coming out and building on top of those. I mean, do you have any experience in or work with any of those, or is it mainly just on the protocol itself?
So I lost you for the critical part where you were asking the question.
That's okay. We can edit it out in post. It's fine. Brent is a very skilled editor, so I can
I
wind
was like,
myself
oh
back.
no. Yeah.
I will absolutely forget to edit this out. This is a behind the
It's
scenes
fine.
look, folks.
It's fine.
It's all good.
No, so my question was that as somebody that's been working in open source, OpenSSL, and the vulnerabilities that have come from that have they often get mentioned, and one of the things which has happened to try and counter some of that is the recent work on the formally verified cryptography libraries that have started appearing, and a lot of research has been going into formally verified crypto. So I'm just curious, as to somebody that's working on TLS itself, is there a push anywhere to make sure that the standard implementation that people are going to be using is in some way formally verified, or are we still living very much in the Wild West of open source implementations?
Well, I think it's a combination of both. So since we were talking about the IETF, right? And I'll mention Quick because that's the next up and coming protocol that, by the way, also depends on TLS 1.3. So by and large, the trends that I'm seeing in the industry is actually in the standardization and the adoption of industry is the adoption, because we're moving so fast, there's that heavy adoption of open source code, right? And so OpenSSL and open source to begin with for the prototypes, and then paying, the likes of OpenSSL, if you will, for that quick adoption. And so, when you look at the vulnerabilities, absolutely. The reason why I'm saying it's a combination of both is, by and large, as we look at the designs of these new protocols and interfaces, right? We need to get that beyond the quick adoption of these protocols, right? We need to vet out the interoperability and the security of it, absolutely. And so the interoperability is being taken care of by the quick adoption of these as we stand up these, hey, I believe, we need to go towards quick, if you will, right? By the 9-month time frame, I think there were 5 different open source implementations to look at, right? And so now you get into, how do we get into formal verification of the implementation as well as the security of the protocol itself, right? And so the academia will still come into play to help with that, as well as some of the external sources. But this is where we're in this cycle, right? Even those are coming in via open source as well. And so that's where, I call that the supply chain, or the pipeline, if you will, of how do we ensure that that pipeline becomes secure, right? And the two that have become very critical in my mind from a security perspective is that dominance of JavaScript. And I forget, a couple years ago, there was that leak in Java, that breach, as well as with OpenSSL, right? Because by and large, from my lens, those are the two main ones that are so massively widely adopted that, I don't know I don't have a good answer, because it's at a global scale, right? So you can't just point to one government agency to say, hey, how do you help us, ensure that there's some metric for us, to measure their today the security, and then I do think that with privacy coming into the forefront, that we'll have some regulation, and metric to measure that as well, right?
Yeah, I guess the one thing I always find quite funny about all of this is that with things like the IETF, we're trying to agree on having that interoperability so that we can have potentially all of these differing implementations anyway. But with something which is so critical to the underpinning of communication on the internet, you think that actually we might say, in this case, guys, let's just have one. Let's have one. Let's do it right. Let's all just collaborate on that one, and everything will be fine. In some cases, maybe that proliferation isn't necessarily right.
Yeah. And I mean, I will say, because I've dabbled in the IoT space for a few years, OpenSSL by and large is the pervasive one, right? Except for the embedded systems,
right?
Where you are so code critical, and that's where I would say, so I'm agreeing with you, but I'm also saying, Wolf SSL is the predominant one for these embedded devices, that we should create that short list, right? Yeah. If you will. But yes, I mean, that is an excellent point.
Excellent. Well, Nancy, I think we're coming to the end of our show here, but I think it's pretty clear we need to have you on again, because I think we could get into the whole supply chain security thing, which would be fun to talk about on a future episode. So
yeah, the hour went by fast. It's amazing.
Yeah. Well, thanks so much for joining us. I think our listeners are really going to enjoy it. Yeah. Yeah, definitely. And
thanks for having me. This was fun. Yeah.
Excellent. Yeah, and to all of our listeners out there, thanks for listening to the show, and stay safe out there. Join us again for a future episode of the net.lol.